Magandang buhay mga bata! Tara, samahan ninyo akong matuto kasama si
Teacher Aika, your online teacher. Please don't forget to subscribe, like, share, and hit the notification bell for more videos. Thank you! Matatag Curriculum, Science Grade 4, Quarter 3, Lesson 5. Our topic for today is about describing motion using distance versus time graphs. This is Teacher Aika, your online teacher. Let's start! Learning competency. The learners measure accurately the distance and time when things move using simple equipment. Define the concepts of distance and time as they relate to motion. Familiarize oneself with simple equipment to measure distance and time like a meter stick, ruler, measuring tape, and stopwatch. The learners identify that how far an object moves in a given time is called speed. Calculate the speed of a moving object. Recognize the importance of having accurate measurements in describing motion. Describing motion using distance versus time graphs. How to construct and label a simple line graph. Day 1. Let's have a drill. Recite the definition of the word flashed on the card. Distance, position, speed, motion, and travel time. Today, we're going to learn a special trick to track how far something travels over time. This trick will let us create a picture called a graph that shows us exactly how fast and slow things are moving, even if we only see them at the beginning and end. Have you ever wondered how we can show whether a car is going faster or slower even without watching it move? Imagine you're racing your friend on your bikes. How can you tell who's getting further ahead without constantly looking back? Let's start. Unlocking Content Area Vocabulary. Title. It describes the content or purpose of the graph. Axis. The line graphs contains two axes. Example, the x-axis or horizontal and y-axis or the vertical. The x-axis typically represents the independent variable, example, time, while the y-axis represents the dependent variable, example, distance. Labels. The name given to the x-axis and y-axis. Line. It is the line segments that is used to connect two or more data points. Describing motion using distance versus time graphs. How to construct and label a simple line graph. Can you think of a time when you had to travel somewhere? How far was it? And how long did it take? How can we represent the journey from home to school on paper? What information do we need? Let's have a storytelling. Imagine you're watching a race. Cars zip across the track, creating a blur of color and speed. But how do you truly know who's winning? What if we could capture the excitement of the race, not just in snapshots, but in a story of movement? That's exactly what line graphs do for motion. Think of each car in the race as a dot on a line. As time ticks by, those dots race their journey across the graphs, revealing secrets about their speed, distance, and even how they change pace. It's like painting a picture of the race with numbers, a language that unlocks the mysteries of motion. So, why are line graphs so important in understanding motion? They make invisible visible, and they tell stories of motion. Day 2. A line graph is a unique type of graphs that is commonly used in science. It is particularly useful for displaying trends and changes over a continuous interval or period. Before making our first line graph, let us first know its parts. Let's have them one by one. Title. It describes the content or purpose of the graph. For this example, the title is Leia and John's weekly basal heart rate. Axis. The line graph contains two axes. Example, the x-axis or the horizontal line and y-axis, the vertical line. The x-axis typically represents the independent variable, example, time, while the y-axis represents the dependent variable, example, distance. Labels. The name given to the x-axis and y-axis. Line. It is the line segment that is used to connect two or more data points. Data point. A data point represents a specific value or measurement for a given variable at a particular point in time. Let's have the worked example, our first line graph. Using the sample data below, guide the learners in making their first line graph. This data shows the speed of a car as it runs towards the north. So we have column 1 for time and column 2 for distance. How to draw line graphs. First, label the axis. Add labels to the x-axis and y-axis. You can also include the unit of measurement. Second, determine the variables. Add labels to the x-axis and y-axis. You can also include the unit of measurement. Third, use appropriate scales. Based on your data, determine how many units each grid line or division represents. The x-axis and y-axis must have equal intervals based on your chosen scale. Fourth, plot the points. Plot the individual data points on the graph according to the given data. The time goes on the x-axis and the corresponding position goes on the y-axis. Fifth, connect the points. After plotting the points, you have to connect those points with a line. Sixth, add title. After completing the graph, you should provide a suitable title. Seventh, interpret the graph. Look for patterns such as constant speed or periods of rest. Consider the slope of the graph as it provides information about the speed of the object. 8. Review and revise. Review your drawing. Here are the guide questions. What does the graph show us about the speed? And this is what the line graph looks like. Let's interpret. Based on the data in the table, we have time 0, 1, 2, 3, 4, 5 in seconds. Distance in meters 0, 2, 4, 6, 8, and 10. The graph would show a straight line when plotted because the distance increases by the same amount, 2 meters, every second. This tells us that the object is moving at a constant speed. Speed is equal to distance divided by time is equal to 2 meters per second. Interpreting distance-time graphs. For a better understanding, the teacher may consider presenting this kind of graph. This is just an example and describing what the graph shows us about speed. So this graph shows how something moves over time. Blue line is the fast, steady speed. Starts at 0 distance and quickly rises over time. Red line is the stationary and returning. Starts moving steadily, then becomes flat at 30 meters or stationary. Green line is getting faster. Starts slow, then curves upward, showing it is speeding up. Day 3. Lesson activity A. Graph it. Meet Turbo Turtle. He's not your average turtle. Today is the Great Reef Race, and Turbo is determined to prove he's the fastest underwater swimmer in his class. He sets off from the starting line, zipping through the coral tunnels and seaweed forests. But watch out for Mr. Stingray, who likes to zoom past and splash Turbo with his tail. And here is the table for Turbo's data and describe his motion throughout the race. So first column, we have time, and second column, we have distance. Here are the process questions. Number 1, what does the graph show about turbo speed at the beginning? The answer, at the beginning, we have 0 to 2 minutes. Turbo moves steadily, covering 5 meters per minute. Number 2, what happens to the line at 3 minutes? The answer, at 3 minutes, Turbo stops moving forward and goes back to retrieve his goggles. The distance decreases from 15 meters to 10 meters between 3 to 4 minutes. Number 3, does Turbo ever catch up to his classmates? The answer, Turbo resumes moving forward after finding his goggles at 4 minutes and continues at a steady pace. But based on the table, it's unclear if he catches up with his classmates without additional information about their distance or speed. Letter B, who ran faster? James and John were walking to school when they decided to race against each other. Using the data below, make a line graph of both James and John's motion in one plot. Follow the steps in making a line graph and find out who ran faster between the two. So here is the data. First column, we have time. Second column, James' distance. And third column, John's distance. Clue, the line graph that is steeper than the other is the one that moves faster. Process question, who ran faster? Here's the graph showing James and John's race. The red line for John is steeper, meaning John is faster than James. James moves slower as shown by the blue line. Day 4. Learners' takeaways. In a sheet of paper, let the students write and arrange the steps in making a simple line graph. Review and revise, determine the variables, add title, choose appropriate scale, label the axes, connect the points, plot the points, and interpret the graph. Answer key. Number 1, label the axes. Number 2, determine the variables. Number 3, Choose appropriate scales. Number 4, plot the points. Number 5, connect the points. Number 6, add title. Number 7, interpret the graph. And number 8, review and revise. Formative assessment. Examine the distance versus time graphs below and identify which among them is stationary, moving at a constant speed or going back. Graph 1. The line is going downward, which means the object is going back. Graph 2. The line is flat, showing no change in distance. This means that the object is stationary or not moving. Graph 3. The line is going upward at a steady pace, which means the object is moving at a constant speed. Letter B. Analyze the graph below and identify who runs faster, Juan or Miguel. Observations. The steeper line indicates a higher speed because it covers more distance in less time. In the graph, Miguel, or the orange dashed line, has a steeper slope compared to Juan, or the blue solid line. For the conclusion, answer: Miguel runs faster than Juan. And that wraps up today's lesson. If you enjoyed this video and want to see more content like this, don't forget to hit the subscribe button and ring the bell so you never miss an update. Thanks for tuning in.